If your Azure application suddenly can't reach external APIs and you're seeing connection timeouts, there's a 90% chance you've hit snat-port exhaustion, and most people don't even know this limit exists until production goes down.
Hey everyone, welcome back to the Network Ninja Cloudcast. I'm so excited about today's topic because I literally ran into this issue last week.
Perfect timing then. Today we're diving deep into Azure Load Balancer Standard SKU snat-port allocation, because understanding this will save you from one of the most frustrating outages in cloud networking.
Okay, so I had my app behind an Azure Load Balancer, everything was working fine, then suddenly my backend couldn't connect to external payment APIs. What actually happened?
So here's the deal. When your VMs behind a load balancer need to reach the internet, Azure uses Source Network Address Translation, or SNAT. Your VM's private IP, say 10.0.1.4, gets translated to the load balancer's public IP. But here's the critical part. Each outbound connection needs a unique combination of source IP, source port, destination IP, and destination port.
Wait, so there's a limited number of ports available for these outbound connections?
Exactly. With Azure Load Balancer Standard SKU, you get a default allocation that follows a tiered scale based on your backend pool size. For pools with 1 to 50 instances, you get 1024 snat ports per instance. But here's what catches people off guard. As your pool grows, that allocation decreases. With 51 to 100 instances, you drop to 512 ports each. At 101 to 200 instances, it's only 256 ports per instance, and it keeps decreasing from there down to just 64 ports for very large pools.
Whoa, so scaling out actually reduces my ports per VM? That seems backwards.
It's a common gotcha. Think of it like a hotel with a fixed number of room keys. Each guest checking out to visit the city needs a unique key to get back in. The more guests you have, the fewer keys each person gets. Once all keys are handed out, new guests have to wait.
So if my application makes lots of outbound connections quickly, I could run out of these ports.
You've got it. And here's where it gets technical. TCP connections have a 4-minute idle timeout by default in Azure, and that's actually the minimum you can set. So even after your API call completes, that snat port stays reserved for 4 minutes. If your app makes 300 API calls per minute and each takes 2 seconds, those ports are still held for 240 seconds after completion.
That math is scary. So 300 calls times 4 minutes of hold time means I could have 1,200 ports in use at any moment, but I only have 1,024 available.
Exactly right, and that's when you hit exhaustion. Your new connections fail with connection timeout errors. Now let's talk prevention strategies. First option, configure explicit outbound rules. In the Azure portal, go to your load balancer, select outbound rules, and you can manually allocate more ports per instance, up to about 64,000 ports per front-end public IP across all back-end instances.
Can I just max it out and give each VM 64,000 ports?
No, and this is important. The roughly 64,000 is the total pool per front-end IP, shared across all back-end instances. If you have 10 VMs, that's about 6,400 ports each maximum. The formula is total ports divided by number of back-end instances. Now here's a pro tip. If you need more than 64,000 total ports, you can add multiple front-end public IPs to your outbound rules to increase the overall pool.
Are there any quirks when configuring this manually?
Good question. When you manually specify ports per instance in outbound rules, the value must be a multiple of 8. That's an Azure requirement for manual allocation. If you stick with automatic allocation, Azure handles that math for you.
What's the second prevention strategy?
Use a NAT gateway instead. Azure NAT Gateway gives you approximately 64,512 snat ports per public IP address per unique destination endpoint. That per destination part is huge. And you can attach up to 16 public IPs for roughly 1 million ports per destination. It's specifically designed for high-volume outbound scenarios. You configure it at the subnet level in your virtual network settings.
Wait, what do you mean per destination? How is that different from load balancer?
Great catch. With Load Balancer SNAT, your ports are shared across all destinations. But with NAT Gateway, you get that full port allocation for each unique destination endpoint. So if you're calling 5 different external APIs, you effectively have 5 times the port capacity compared to Load Balancer. That's what makes NAT Gateway dramatically more scalable.
That sounds way better. Why wouldn't everyone just use NAT Gateway?
Cost and architecture. NAT Gateway charges per hour plus per gigabyte processed. For low-volume outbound traffic, the load balancers included SNAT might be sufficient. Also, NAT Gateway is subnet scoped, so all resources in that subnet use it.
What about from the application side? Can I do anything in my code?
Absolutely. and this is often overlooked. Use connection pooling and HTTP client reuse. In .NET, reuse HTTP client instances instead of creating new ones. Enable TCP connection reuse with keep alive headers. Now, since the idle timeout can only be configured between 4 and 120 minutes with 4 being the minimum, your best bet is application-level optimization. Configure your application to explicitly close connections when done. Use shorter application-level timeouts, and implement proper connection disposal.
Let me make sure I understand. The big mistakes are creating new HTTP clients for every request, not monitoring snat-port usage, and not planning for scale?
Spot on. And here's your monitoring tip. In Azure Monitor, look for the metrics used snat-ports and allocated snat-ports on your load balancer. These let you calculate your actual utilization percentage. Set an alert at 80% of your allocated ports. You can also check snat connection count to track connection patterns over time.
So my 3 takeaways are: understand your snat-port allocation based on backend pool size, and remember it decreases as you scale. Consider NAT Gateway for high-volume outbound scenarios, especially with its per-destination advantage, and always implement connection pooling in your application code.
Perfect summary. And my pro tip: before you scale out your backend pool, remember that adding more VMs actually reduces ports per instance with the default tiered allocation. Either configure explicit outbound rules beforehand, or check your allocation before that auto-scale event ruins your day.
That's a gotcha I definitely would have missed.
That's it for today's episode. If you found this helpful, please hit that like button and subscribe to the channel.
And share this with anyone running production workloads behind Azure Load Balancer.
Thanks for watching the Network Ninja Cloudcast. See you in the next one.